Hey everyone, so we're going to talk about heart failure, but before we do I just want to introduce us to our diagram here. So this diagram's a little unusual, right? I'm not showing any of the vasculature in the form of the aorta that occurs here at the top of the heart. I'm not showing how blood leaves the heart and goes to the lungs and then comes back full of oxygen. I'm not showing any of that because it's not necessarily important to our conversation about heart failure. So what I am showing you is that oxygen-poor blood returns to the heart at the right side, and oxygen-rich blood leaves the heart on the left side. I've also shown you some of the features of the right side, so I've drawn it open here so you can see the ventricle, you can see the atrium, you can see the nodes, which are going to generate the electricity that causes the heart to contract, and you can see the valves, or at least one of the valves, which is going to control the amount of blood that flows from the atrium to the ventricle during an atrial contraction. So those anatomical features are going to be important in our discussion of heart failure, so I wanted to show them to you. This other side of the heart, the left side of the heart, I've drawn closed so that we could see a coronary artery, which is going to carry oxygen-rich blood back to the heart to give it the energy that it needs in order to do what it does, which is, keep us alive. So before we talk about heart failure in specifics, I want to talk about the difference between heart failure and heart attack, because people often confuse these two and they're very different. So heart failure we define as when there's something going on in the heart so that we're not getting enough oxygen-rich blood down into the body. And there can be a lot of different things that cause heart failure, but it's a general term that describes the fact that we're not getting enough energy down into our tissues. A heart attack is when there's not enough oxygen making its way to the myocardium because of a problem with one of our coronary arteries, which causes some of these muscle cells to die. And when they die, you experience a heart attack. So a heart attack can lead to heart failure if there's enough damage to this muscle here, but heart failure and heart attack are not the same illness. They're very different. Okay, so now that we've made that distinction, let's go up here and let's talk about types of heart failure. So we're going to talk about two main types. So the first is what is called high output heart failure. And I'm drawing a little slowly just so my writing is very clear. I did not get great marks for penmanship. Okay, high output heart failure. So high output heart failure is a pretty interesting thing because first of all it's rare, and second of all there's actually nothing wrong with the heart in cases of high output heart failure. What's going on is the body is just asking the heart to pump way more blood than it's capable of pumping. So this happens sometimes when people get blood transfusions and they get way more blood than the body is actually capable of pumping through the circulatory system. It can also happen in cases where people have hyperthyroidism, which is when the metabolism sort of runs out of control because there's too much thyroid hormone in the body. So a good way to think about this is imagine that you're driving your jankety four-door family sedan here, all right, and you're driving down the highway and you see a guy in a Lamborghini and he's doing 185 and you decide you're going to try and race him. So you gun it and you're trying to catch up to him, and you gun it, you're getting to 80, you're getting to 85, you're getting to 90, and then all of a sudden your car just can't go any faster. Well, the reason it can't go any faster is because your engine is just not capable of going any faster than you're going. 90 is the max. There's nothing wrong with your engine, it's just not capable of doing the work that you're asking it to do. That's what high output heart failure is in a pretty simple analogy. So let's talk about the much more common type of heart failure, which is called low output heart failure. Right? So low output differs from high output in that the heart is actually not producing enough blood, enough oxygen-rich blood, and giving it to the tissues. So this is also called congestive heart failure. If you watch the symptoms video, you'll see why we're getting a lot of pulmonary congestion, a lot of venous congestion, because the heart is diseased, it's broken in some way, so blood is not moving through it fast enough, which is causing backup. It's like water behind a dam. It just ends up backing up and causing problems behind the problem. Okay, so the first thing that can cause low output heart failure that I want to talk about is problems right here in the coronary artery. So we can get coronary artery disease. Coronary artery disease is problematic because, as we said before, the coronary artery is what carries oxygen-rich blood into the heart. It gives the heart the energy that it needs to do its work. So when we have coronary artery disease, we're basically keeping the heart from the energy that it needs to work. So real briefly, I just want to describe how this works. So you have a coronary artery, and this coronary artery carries blood. It's elastic. It can carry a lot of blood if it needs to. And when it gets to the tissues that require oxygen, it releases its oxygen. So we're going to draw a bunch of little arrows just to symbolize that oxygen is moving out into the tissues. Alright, so now imagine that we have coronary artery disease. So what does that look like? So let's go over here. Let's draw our artery again. So we have an artery here. And now what's going on here is that there's a bunch of gunk. Okay, they call it plaque. It's basically cholesterol and fats and all kinds of just stuff. And it just sort of gunks up the works. And it makes the artery less elastic, which means that it can't carry as much blood as it used to be able to carry. We're going to make this really diseased. Okay, so when the coronary artery narrows because of coronary artery disease, it means we're going to basically get less oxygen that's moving out into the tissue. Okay, remember, oxygen is our fuel. We need oxygen in order to make a muscle work. So what's going to happen is this muscle is not going to be able to work as well, right? This myocardial muscle. Sorry, I pointed at the coronary artery. I meant to point here at the muscle. So if the muscle is not able to meet its energy demands, it's not going to be able to pump as efficiently, which is going to slow the movement of blood through the heart. It's going to decrease the amount of blood that moves through the heart, which is something that can cause low output heart failure. Alright, so the next thing I want to talk to you about are these nodes. So we have one node here, which is the SA node. We have a node here, which is an AV node. So the nodes generate electrical impulses, right? They generate currents. These currents are going to cause the muscle that they come in contact with to contract, which is good because when this muscle contracts, it's going to force the atrium to get smaller, which is going to push blood down into the ventricle. The same thing happens when the ventricle contracts. It's going to get smaller, which is going to push blood, in this case, up into the lungs. Okay, so it's important that the electrical conduction system here works well. So there are cases when the nodes don't function properly. So we'll call this node malfunction. Let's work on our M there. Node malfunction. All right, and that causes problems in the rhythm of the firing, which we call arrhythmias. Let's see if I can spell rhythm here. Such an unusual word. Arrhythmia. Okay, so let's take as an example the SA node first. So let's say that the SA node fires. So we're going to use a little lightning bolt here. Okay, and this is the SA node. So the SA node fires. So what happens is all of this myocardium here, we should say first, the myocardium is the heart muscle, and don't be confused by the word. Myo means muscle and cardium means heart, so it's muscle from the heart. Okay, so the myocardium is going to contract when this SA node fires, and it's going to cause blood to get pushed down into the right ventricle here. All right, when that current makes its way to the AV node, all right, there's going to be a pause. All right, 1 beat, 2 beats, 3 beats, because we want to give the atrium enough time to contract and push its blood into the ventricle. And just to clarify, when I say beats, I don't mean heartbeats. I mean musical beats. I mean moments of hesitation. There aren't 3 heartbeats after the firing of the SA node. So just so we're on the same page. All right, so once enough blood has made its way into the ventricle, we're going to have another firing. So we have our second lightning bolt here. Okay, and the AV node is going to fire. So when that happens, we get blood that's moving out into the lungs. So what happens, say, if the delay between these two is shorter? Say it's 2 beats instead of 3. Well, imagine what would happen. The atrium would contract, but before enough blood has been made to go into the ventricle, the AV node is going to fire. And what happens with the AV node fires? This ventricle contracts. So basically, because this AV node fired a little bit quicker than it would have in this other case, we weren't getting as much blood into the ventricle before it fired. as we would if the nodes were not malfunctioning. So you can see that we need the rhythm of the firing between these nodes to be correct so that we can get a maximal amount of blood moving through the circuit. If there's a problem in the firing, if there's arrhythmia, which is a problem in the rhythm, or if one of these nodes, say, just doesn't work well, right, we could get a case where we're not moving enough blood through the body, and we could get congestive heart failure. So the third thing I want to talk to you about are these valves. So this is just one example of a valve. There are actually 4 valves in the heart. So there's valves that connect the atrium to the ventricle in each case, and there are also valves that connect the ventricle to the arteries that they're filling into. So if we have valve malfunction, we can have a bunch of different problems. So imagine right now that the valve is a gatekeeper. All right, so when the atrium contracts, the valve opens so that blood can enter into the ventricle, and when there's enough blood in the ventricle, that blood pushes back against the valve so that the valve closes, which basically keeps blood from moving back into the atrium. So what happens, say, if this valve were, say, sticky or rigid and it wasn't allowing enough blood to move through the ventricle? You know, it's narrowed and it's not able to open up all the way, so we don't get a maximal amount of blood in the ventricle. Well, when the ventricle pumps, it's not going to pump enough blood down the circuit, right? So we're going to have a problem here. You can also imagine a case where the valve might not close up well, so it opens up well, but it's sticky when it tries to close, which means that blood can escape back into the atrium, which means that there's not as much blood down here in the ventricle when the contraction happens. So those are just 2 ways that the valve can go wrong that can lead to heart failure. So the last thing I want to talk to you about here is the myocardium. So the myocardium is this muscle that surrounds the chambers that we've been talking about. So we can get problems with the myocardium, and when something goes wrong with the myocardium, we say that patient is experiencing cardiomyopathy. So let's break this word down real fast. So cardio meaning heart, myo meaning muscle, pathy meaning illness. So we have an illness in the muscles of the heart. So we can have a variety of different illnesses that affect these muscles, and they can come about because of viruses, because of bacteria, for a lot of different reasons. So we're just going to talk generally about what goes on. So what happens sometimes is that the muscles, they get weak and they're not able to contract as hard, they're not able to maintain their structure, and they expand. They get weak and they expand. When this happens, the heart wall dilates and becomes weak. So this is called dilated cardiomyopathy. Right? And this is a problem because, 1, the heart is going to overfill, and 2, because what the dilation shows is that the heart muscle has become weak, which just means it's not going to be able to do the work that it's normally capable of doing. So if it's not able of doing the work, right, you're going to get not enough blood moving through the circuit, which can lead to heart failure. All right, so we can have the opposite case where the walls of the heart become stiff and rigid. All right, when that happens, the ventricle cannot fill near as much as it used to, which means you're not going to be moving enough blood through the circuit, right? Because basically you just can't fit enough blood into the ventricle to make it work efficiently. So that's called restricted cardiomyopathy. Okay, so that's just a couple of examples of how the myocardium can become diseased, and how that diseased myocardium can lead to not enough blood being pumped through the heart and not enough oxygen-rich blood making its way down into the tissues.